Oh, okay. All right, so 4 gave me this. I hope y'all got the slope field. I wish I had my document camera so I could kind of show you. I just went through every single point. And you only have to do the ones with the black dots on the knife. There. Yeah, you didn't have to do the ones on the x-axis. So it did something like this, like it was a negative slope and then a steeper negative slope. I did this one anyway, it was 0. This one went something like this. What? What do you like? The pink? Or the slope field? This. And then this one was a lot steeper at a positive slope. But somewhere around there. That was actually 2 points. They gave you 1 point if you got everywhere the slopes equaled 0, which for what they gave you looks like it was just this one. And then 1 point for where x, oh no, 1 point where x equals 1, and 1 point where x equals 0. So 1 point for this column and 1 point for this column. Odd. That's what they did. So 2 points there. Y'all at least get those 2 points. Pretty easy. Plug into that. Do y'all need me to do any of those? Y'all know how to do those? Okay. Part B says to find the second derivative in terms of x and y and determine the concavity. So we'll start with the second derivative. So we are given the first, and it asks us to find the second. So for the second derivative, remember, anytime I take the derivative with respect to x, I need to, of y, I need to follow with a dy dx. And for that, all you have to do is plug this back in here. So your second derivative ends up being 2 minus 2x plus y, because you have to subtract all of that. And then it asked you for concavity. So that was 1 point. There's 1 point for your second derivative. And then concavity, because this is second derivative and they ask you about quadrant 2, here's the way I thought about it. If I'm in quadrant 2, I'm here, right? And that means x is negative and y is positive. If x is negative, that means that I'm always going to be multiplying by a negative. So I'm plus some number, some positive number. And then if y is also positive, I'm adding it. So I'm always positive. So what I said was, because the second derivative is greater than 0 in quadrant 2, then y is concave up. I'm going to say no because it says in terms of x and y. If it didn't have that in terms of x and y, I would say maybe. But because of that, that means the only variables in there need to be x and y and not anything else. Sometimes they don't write. I'm so paranoid that I write so much every time because they're like that. Sometimes it's a lot, and sometimes it's not a lot. No, no. So you said the second derivative was positive in quadrant 2. I would say, and so you said it's concave up. I would say that you get 1 over 2 points. So in quadrant 2, x is always negative, right? And y is always positive. So if I look back at this equation that I have for my second derivative, this is always positive, so it's not impacting. And if I'm adding y and it's positive, that's going to keep me positive. So really, I'm looking at this middle term. Well, if I plug in a negative number for x, and then I'm multiplying it by negative 2, that's always going to give me a positive value. So this is always positive when I'm in this quadrant. So since the second derivative is positive, that means concave up. That one was a little bit confusing, limiting it to a quadrant instead of a range of numbers. All right, part C. Let y equals f of x be a particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have a relative minimum, maximum, or neither at x equals 2? So you had to really think about this. What tells me maxes and mins? Where the slope changes. And what gives me the slope? The derivative, right? They gave me that dy dx. It's so by what I'm getting at is by plugging in here, I know the slope. If it's a max or a min, what does the slope have to be? 0, because that's where it changes. It changes when it's 0. So if this is 0, it's a potential max or min. But if it's not 0, then I don't have to go any further. There's no way it could be. So if I do dy dx at the point 2, 3, I get 2 times 2 minus 3, which is not 0, right? Therefore, it cannot be a max or a min because the derivative does not equal 0. You actually got 1 point for plugging the point into the derivative. So if you did this much, you got a point, and then you got a point for the explanation. Or saying that it's, because it doesn't equal 0. And you had to say, because, see, I said, since the derivative does not equal 0 at x equals 2, 2, 3 is neither a max or min. So however you worded that, same. But you had to say that because it doesn't equal 0. Well, remember, whenever you take the antiderivative, you've got that constant of integration. There are an unlimited number of solutions. So they're just saying, let it be one of the solutions. So think about how you find, if I gave you f of x and I said, find the maxes and mins, you would take the derivative of it, right? And that's only the none. Part D. Okay, I'm not going to lie. I don't know how they came up with part D. So y'all can help me out and see. Maybe we can bounce this around each other. I don't know. I got 2 of the 3 points, but I could not make it stretch. And I went back and looked and looked and looked. So let me tell you what I did. You can tell me what you did. We'll see if we can come together. Find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So if it's a solution, that means dy dx, which they already gave me, right, is equal to the derivative of this. So I took the derivative of this, and I said dy dx equals m. Right, because that's the derivative here. And then I took their dy dx, and I set it equal to my dy dx. So I said 2x minus y, because that's what they said, right? Or that's what they gave me in the beginning, equals m. Or that's what I got my dx to be. If it's a solution, that should work. Okay, so far, that's 2 points worth right there if you got that. I got those 2 points, yes. You got a point, you got 1 point for taking the derivative of the first equation. Remember how I always tell you take the derivative, take the derivative? You got a point for that. I felt like this question was out in left field, like way, way, way out there. Then you got a point for setting their dy dx equal to your dy dx. That was another point. Now from there, they got m equals 2 and b equals negative 2. And I can show you what they did, and it makes 0 sense to me. I got their equation. So as I kept on solving, right, let me show you what I did. And did any of you get this one, by the way? You got this part. Did you get the answer? 2 and negative 2? Nobody? There's no numbers. Okay. Let me show you what they did. Okay, well, let me show you what I did, and I'll show you the point where I stopped, because I said there's no way, there's too many variables, I can't solve it. All right, so I replaced this y with what I knew y to be, which is mx plus b, right? So now I have 2x minus mx, and I'm just going to distribute that through. And then I just started working with it and just trying to see what I can get. They did the same thing. I went back and looked at theirs. They did the same thing, but they went way further than what I did. I put like terms on the same side, or tried to put as like as I could get. I put what did I do? I kept the x's over here. I moved that b over there, and I factored out an x. And I said x times 2 minus m equals. I added that, and here's where I stopped. Because I said, there's no way. This is not working. There is no way you can get an answer. They got to this point, and this is what they said. I'm just going to write you what they did. They didn't have this b plus m on that side. They had x times 2 minus m minus b plus m equals 0. They said, therefore, 2 minus m equals 0, which means m equals 2. And they said b equals negative m, which means b equals negative 2. Like, I'm thinking they're factoring and they use zero product property, but that's a subtraction sign, not a multiplication sign. They sub something in somewhere back some. I see if they got 2 here. I see where this can. I don't know. They set each of these to 0 for some reason, essentially. And I don't understand why. I don't think that that's legal. Right, for it to be 0. That was where I stopped, was that they had to be equal to each other. But equal to each other doesn't necessarily mean 0. I don't know. I don't mind. Anyway, but there's your other point. I didn't get that point. I still wouldn't get that point even looking at the solution now. Okay, let's move on to 5. I was a little embarrassed to have to show y'all that, but I mean, sorry, I don't know. All right, number 5. I also did number 5 differently than they did, but I would still give myself a point to put up the right answer. Everything was legal. That was on D, though. My D is a lot different than their D. So I'll show you what they did and what I did. But let's start with A. We got this picture. I went ahead and marked my picture up whenever I started because y'all know I do that. They gave me some values here. This first one ended up, I think they said 9, and this was 12. Is that right? Yeah. So remember, that's the areas. So they gave it to you in the positive, but if I'm talking about an integral, it's negative. So be careful there. Part A asked me, and by the way, this was -2, this was 1, and this was 4. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. Remember, this is the graph of the derivative. Of course, I did a little sign chart because that's the only way my brain wraps around it. Because it asked for relative, you don't have to worry about endpoints. Only when it asks for absolute, that's when you use that strange value form. So I'm looking for zeros of the derivative. So I tested at -2 and at 1. It was positive, negative, negative, which means you have a relative maximum at x equals -2 because the sign, and you always want to reference what they give you, okay? So don't ever say because that's a maximum on the graph of f or whatever. Always go back and reference what they give you, even whenever we get further. So because the derivative, or because f prime changes from positive to negative at this point. That was 2 points, one for identifying x equals -2, one for the justification. Then if you had your little sign analysis already on here, it made part B a lot easier because it said concave down and decreasing. So you've already labeled the parts that are decreasing. So I just came right below it and I did another little line. I'm looking at the second derivative, but because I'm given the graph, this is when I'm looking at slopes, right? All right, so where is the slope changing? Here, here, and here, right? Which is -1, which falls kind of in between here. What else did I have? 1 and 3. Slope is negative. Slope is positive. Slope is negative. Slope is positive. And so then I just went through and found those overlapping that are decreasing and, I already said, decreasing and concave down. So decreasing -2 to -1. And then 1, 2, 3. One point for the intervals, and then your reasons. And here's where it's really important. Make sure that you use F prime to describe, to justify. So because F prime is decreasing and negative on these intervals. Did you say the second derivative was negative? I think you would probably get 1 out of the 2 for the reasoning being correct, but missing 1 of the intervals. Yeah. Other questions about that? Part C. Find the x-coordinates of all points of inflection. Again, if you already did this in part B, your work's kind of done for you, right? So I didn't have any work to show for that. I just went back and said, okay, well, x equals -1, x equals 1, x equals 3. There's 1 point. And then your reason, I put because, remember, you always want to reference what they gave you. Because f prime changes from increasing to decreasing or decreasing to increasing at each. What was your, I would say you wouldn't get it for the answer part, but was your reason right? Did you say that the slopes were changing at those points? I would say probably not, because they want to see that. I have to look that up because you're right. My question is, can you have a horizontal tangent without a change in slope? Yes, because then that would make it non-differentiable. Yeah, because we did talk about horizontal tangents and vertical tangents. That's so probably not. Although, good reason. Yeah. Sorry. Ooh, the second derivative equals 0, but in this case, we're looking for where the first derivative, the slope changes. I think you have to talk about, I think it's probably going to depend on your reader on that one. A good habit to be in is always talk about what they give you. The first derivative goes from increasing to decreasing or decreasing to increasing. I don't know. I mean, if I'm reading that, I'm probably giving you a point for that because you obviously understand the connection and you understood that. I don't know that they would. Probably depend on who you got. If you got Verge, probably. If you got Martin, not. What F would look like? All right, so okay, so I'm increasing in concave down, right? I'm increasing in concave down, and then I'm decreasing in concave up, and then I'm still decreasing but concave down. But all right, so increasing concave down, that's the interval. Now I'm concave up but decreasing. Up. Still decreasing but concave down. Decreasing but concave up. So it'd be kind of funky. We did, yeah. Maybe a multiple choice question or two usually, but not usually on FRQs like that. All right, part D I thought was the doozy. Y'all ready? Given that f of 1, I'm going to show you how I did it. I'll tell you what they did then. Write an expression for f of x that involves an integral and then find f of 4 and f of negative 2. What I did was I said, well, the integral, I first did the integral from negative 2 to 4 of f of x, but then you have to set it, if you do that, then you have to do f of 4 minus f of negative 2, neither one of which you have, okay? So then I went back, I crossed that out, because don't waste your time erasing a bunch of stuff, just cross out. And I went from 1 to 4. Now, why did I do that? Because I looked at what was given. Remember, I wrote on my sheet again that this area is 9, this area is 12. And I knew I wanted to use this 1 because they gave me. So what can I go from on my graph where I know the area? Well, I could go from 1 to 4, and I know that area is 12. So I said this would be f of 4 minus f of 1. I know that this is 12. This is actually negative 12, right? Because it's below. F of 4 minus 3. Solve that, so I've got negative 9 is f of 4. Then I went back to that one that I was going to start with, that from negative 2. They give you, oh, yeah. Okay, that's the way they did it. You did it the same way they did it. Yeah, you could have done that as well. You could have done that as well. But whenever you go through and you solve it, either way you go through, you solve it, you find that f of negative 2, right? So if I'm in this same mindset here, then f of 4 minus f of negative 2, well, from negative 2 to 4 would give me 21. Negative 21, actually. And I went kind of around my butt here because y'all did it a little bit better than I did. But I added 9. Yeah. She'll be okay. What? What? From -2 to 4. I added. They gave me each of. Yeah, I added them together. You probably get 2 out of the 3 points because you get 1 point for the integrand, 1 point for finding f of well, they said for f of x. I never found f of x. I guess that's why I messed up on this one, y'all. I didn't read that part. It says find an expression for f of x. Yeah. Yes. So their f of x was f of x equals, and I think, Lainey, this is what you did, 3 plus the integral from 1 to x of the derivative. But you found f of 4 and f of -2? I don't know. I would probably give you 2 out of 3 on that one if that was the only thing you messed up on. Where did they tell you that on this one? Oh, so that you know those are maxes and mins. You know that's where the derivative equals 0. So for part A or B, it could help you with that. So you don't have to actually look at the graph. You could just pull in from there. If it's got a horizontal tangent, that means the derivative is 0. So instead of looking and estimating, I think that's got a minimum at x equals -1. They're telling you, yeah, it does. It doesn't change signs, but it is a 0. It's one of those bouncers, but yeah. All right, so I thought that one was tough too. I thought part D on that one was tough too. All right, let's do 6. 6 I thought was the easiest. No? Come on, Robert. Write an equation for the tan line to the curve at -1, 1. So for tan line, you need a point and a slope. The slope is given to you here, so really, I need the derivative at, what did it say, 1, -1, 1? And that's just a plug-in kind of thing, right? So 1 cubed minus -1 times, oh, wrong equation, 1 over, I did it right on my paper, and I'm still, oh, 1, which gives you 1/4. You've got 1 point for finding the slope here. And then the equation, well, they gave you the point -1, 1, so y minus 1 equals slope times x1, or y equals 1/4 plus 1. There's another point. That was a 2-pointer. I thought that was an easy 2-pointer. -1 minus x, what? You did x1 minus x instead of x1. Yeah. Vertical, any point where the tangent to the curve is vertical. So vertical means that your slope is what? Undefined. The only way it can be undefined is when? Bottom equals 0. Did you take 3y squared minus x that is equal to 0? That gives you a point. That gives you a point just setting it equal, even if you went, I have no earthly idea what to do from there. But I know undefined means bottom equals 0, so you got a point. So then I went through and said, well, 3y squared equals x, right? And now what I want to do is I need to get my equation into just one variable so that I can solve it. So instead of solving for y and plugging in, it's already solved for x. So I took that initial equation, this one, and I plugged in 3y squared instead of x. So I got y cubed, so y cubed minus 3y squared times y. I solved that for y. Negative 2y cubed equals 2, so y cubed equals negative 1, which means y equals negative 1. By the way, if you got your equation into just one variable, even if you solved incorrectly, that was the point. You don't get your last third point until you get your final answer. And then I plugged this one back in. You could plug it in really. Oh, here we go. Into that original equation. Negative 1 cubed minus x times negative 1 equals 2. And I just solved it for x and found that x equals 2. So there's your other point. 3 points there for that one. Yeah. 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 So, yeah. And sometimes it'll be more than one. Like if you had a square root and you had to do plus or minus kind of thing. That one that's stapled together, I think it's yellow. I can't remember what color it is. But it has all those little quirky things on there too. It is. It is. So, yeah, like when the tan line is horizontal, we're talking about a slope of 0. When the tan line is vertical, we're talking about when the slope is undefined, which means the bottom equals 0. If not, let me know, and I'll try to write something up for you. All right, part C. Part C was worth 4 points, which I thought. All right, so it said evaluate the second derivative. Well, to evaluate the second derivative, we have to find the second derivative. Let me just write this. Let me write the first one above it so you can follow what I'm doing. This was a fun one, I thought. Here's the first. I had to use the quotient rule here. So I did. Derivative of the top times the bottom minus the top times derivative of the bottom. And at this point I went, they have lost their ever-loving minds if they think I'm going back at this point. Because I'm not plugging in for dy dx here because that's what you have to do, right? But I stopped because look at where you're finding this at the point negative 1, 1. Why does that look familiar? I already did that. I already found dy dx at the point negative 1, 1. I found that in part A, and it was 1/4. So at this point, I just went, oh, this became so much easier because since I'm doing it at that point, then that means 1/4 times y is 1. Y is 1. I did though. I was freaking out because I was like, there's no way I'm plugging all that in. This is a non-calculator problem. No way they wanted me to do all that. Theoretically, you could have left it at that point. I'm extra. 1/4 times 3 minus negative 1 is 4. That was nice. 6/4 minus 1, which would be 3/2 minus 1, which is a half, right? Over 4 squared, which is 16. So 1 minus a half divided by 16, which is a half, times 1 over 16, which is 1 over 36. All right, you got 2 points for implicit differentiation. So 2 points for finding the second derivative. You got 1 point for the substitution of dy dx, whether you did that as an equation or you did it as the point that you had already solved for. You got a point for that, and then 1 point for the answer. Which, I mean, theoretically, you could have left like that. So that one was 4 points. Okay. How'd y'all do? Okay. We're at least better than we were those first ones we took, right? Where we were goose egging every one of them.